Python is the go-to programming language for doing AI and data science. Although no-code solutions exist, if you want to build fully custom AI projects and products, learning Python is still essential. In this video, I'm going to give a beginner-friendly quick start guide to learning Python specifically for AI projects. And if you're new here, welcome. I'm Shah. I make videos about data science and entrepreneurship. If you enjoyed this content, please consider subscribing. That's a great no-cost way you can support me and all the videos that I make. This video is going to be broken up into three main sections. First, I'm going to start with a high-level introduction of Python and who this video is made for. Second, I'm going to walk through the fundamentals and basics of Python. And then finally, I'm going to share an example AI project showing how we can use Python to create a research paper summarizer and keyword extractor. Starting with the super basic question of what is Python. Python is a programming language, which is simply a way to give computers precise instructions to do things that we can't do or just don't want to do. One example of this from my world is I'll send follow-up emails after consulting calls with clients. So the current process is we'll have the call, I'll get on my laptop and type up a follow-up email, and then I'll send the client the email. However, if this was something that started to get out of hand and I ended up spending hours every week writing follow-up emails, I might create a Python script that would do this. Instead of me typing up the email after the call, I could create a Python script to do this automatically. And this is just one random example. There are very few constraints on the things that you can do with Python and AI. Another thing I want to highlight is that coding now is easier than ever. Two of the major reasons for that are Google and ChatGPT. So for example, if I wanted to figure out how I can send emails automatically with Python, my first thing might be I just go to Google and type that into the search bar, and then I'll get results that look like this. So Stack Overflow, if you're not familiar, is a very popular developer forum where people are constantly sharing their questions and more experienced programmers are sharing answers. The power of things like Google and Stack Overflow is that it taps into the wisdom of the crowd. So a key thing here is that no individual knows everything about Python. However, if you get a collection of people together, their collective knowledge far exceeds any single individual. And this is something that you can tap into using forums like Stack Overflow or just generally browsing the web. The second thing that's really become a game changer for a lot of developers is ChatGPT and other tools like it. Another option here is instead of typing this into Google, is you might type this same prompt into ChatGPT. So if you type this into ChatGPT, it'll give you a step-by-step answer as well as example code. However, that's not the only benefit of using ChatGPT for coding questions. One of the most powerful aspects of it that I really enjoy is the ability to ask follow-up questions. So if there's something that doesn't really make sense here, like what is the meaning of MIME, or why is it called SMTP lib? Just these random questions that I might have, and these might be questions if you asked a regular developer or programmer, they might get annoyed at you because you're getting way too into the weeds or getting way too pedantic. But ChatGPT is eternally patient and can answer almost any beginner level question with a high degree of accuracy. I'm making this tutorial with a specific audience in mind, namely people who are learning AI and have done some coding but are brand new to Python. Some examples of this might be someone who works as a consultant or even a business intelligence analyst. Another demo I have in mind are students or recent graduates, but also seasoned developers who might just be new to Python. This is not meant to be a comprehensive introduction or overview into Python. Rather, the goal here is to simply give you just enough to get you started coding your very first AI project, and doing that as quickly as possible. So with that, let's just jump into the basics of Python. The first thing is that most computers come with Python pre-installed. So the first thing to do is to check if you have Python installed on your machine. If you're on Mac or Linux, you can do this through the Terminal app, or if you're on Windows, you can do this via command prompt or even PowerShell. I can show you what that looks like real quick. Here we have Terminal opened up, and I'm simply just going to type in Python. If I do that, we can see the Python version that we're using and has some basic instructions instructions. With this, we are in Python right now, and we can go ahead and start coding. However, if you type Python and this does not come up, that means you're gonna need to install Python on your machine. That's actually pretty straightforward. If you are on Mac, you can go to this link here. If you're on Windows, you can go to this link here. And of course, I'll share these in the description below. But just seeing what that looks like, this is the official Python documentation. And if you go to this Python website link here, it'll have a set of downloads for stable releases of Python. So if you're on Mac, you can go ahead and click this thing and it'll download an installer you can use to get Python on your machine, and a similar thing for Windows. Alternatively, there's a popular Python package system for data science called Anaconda. This is available for Windows, Mac, and Linux. So this is another way you can install Python, and this has some handy features beyond the base installation of Python. Now that we've confirmed we have Python installed, let's start digging into some key concepts and code. The first thing I want to talk about are data types, which are simply a way to classify data so it can be processed appropriately and efficiently. One example of this are strings, which are character sequences, which we can use to represent arbitrary text. Here are some examples of strings: hello, and hello's spelled with numbers and special characters. We can also go back to our terminal here and start typing strings. So hello is an example of a string. We can also write strings with single quotation marks. So this is another way to write strings. Fundamentally, there's no difference between using the double quotes and single quotes for strings, but what that does allow you to do is to use quotations in your strings themselves. For example, if we wanted to have the string Shah said Python is awesome, the double quotation marks is going to cause an error. However, if we use the single quotes, whoops, messed it up. However, if we use the single quotes, we can have this be a string. And the last thing I want to show here is we can also use triple quotes if we want to have strings across multiple lines. And then you'll see that this new line character will appear in our string. Some other data types that we can use to represent numbers are ints, which are integers, and floats, which are numbers that contain decimal points. So going back to our terminal, an example of an int is 1, 2, 42, just like in math. Floats would be anything with a decimal, so 1.0, 3.14. And then we can add two of the same data types together. So we can add two integers, we can add two floats. We can even add an integer and a float, and then Python will automatically convert the integer into a float before doing the operation. And we can even add strings together. So here's an example of that. So here we've added a string together. In other words, we've concatenated it. However, we can't add a number to a string. So if we try that, we'll get an error. Although ints and floats can be added together, ints, floats, and strings cannot be added together. If we wanted to do that, we would have to write one as a string. Another fundamental data type are lists, which are ordered collections of values. Some examples of that are shown here. We can have a list of strings like ABC. We can have a list of integers like 1, 2, 3. We can also have a list with mixed types. So we could have A, 2, and 3.14. And we can even have a list of lists. This flexibility makes lists a very handy data type when doing AI and data science projects. The final data type I'm going to talk about are dictionaries, which are key value pair sequences. What that looks like is a little different than a list. So instead of the square brackets, we have these curly brackets, and then we have key value pairs, where each item in the dictionary consists of two parts: a key, which will always be a string, and a value, which can be any data type. And so a simple dictionary might have a single item with a key called name and a value of Shah, which is my name. Something a bit less trivial is to have a dictionary with multiple key value pairs corresponding to the name, age, and interests of a individual. So here have the name as Shah, have age as 29. So you notice that this is an integer, and then interests are organized in a list. So we have multiple data types in this dictionary. But we can also combine the list and dictionary data types. So we can have a list of dictionaries. Here, instead of just having a dictionary corresponding to one person, we have two dictionaries corresponding to two different people. So we have Shah, who's 29, interested in AI, music, and bread. And then we have Iffy, who's 27, who's interested in marketing, YouTube, and shopping. The last thing is we can also have a dictionary within a dictionary. The way that looks is we might have a key value pair corresponding to a user, and the value for this item will be another dictionary, which includes user information. Then the other items in the dictionary might be the last login date and the membership tier of that user. The next thing I want to talk about are variables, which are abstract representations of underlying data. So far, we've just written data types explicitly as SHA, or a set of numbers, or a list, or a dictionary. If you had to continuously write out lists and dictionaries in your Python code, it would become very tedious very quickly. This is where variables come in. What we can do is, instead of writing SHA over and over again in our code, we might create a variable called username and set it equal to SHA. And then anytime we wanted to plug in the user's name, we could just use the variable instead of writing it explicitly. So if we printed the username variable, we would see SHA in the command line. A more sophisticated example is we can define two other variables, one called the user's age and another one called user interests, which are a int and list respectively. And then we can print those out in this way. The output of this is Shah is 29 years old. His interests include AI, music, and bread. Not only does this save us from writing strings, ints, and lists over and over again in our Python scripts, it also allows our scripts to be much more flexible. Because now let's say we wanted to print this sentence for another user. So instead of just hard coding this, instead of writing this explicitly in our script, we can simply plug in a new username, a new user age, and a new user interests list. Another thing I want to call out here is here we're seeing yet another way to write a string. So we saw we could write a string with single quotes, double quotes, and triple quotes. Here is an example of a formatted string. This is helpful when you dynamically want to convert a set of data types to a string. Here we're seeing username, which is a string, user age, which is an int, and user interests, which is a list, all dynamically concatenated together as a string, and then we can print the resulting string like this. These days, where a lot of AI code might involve creating prompts and sending prompts to large language models, formatted strings are a very handy functionality when creating prompt templates for these types of use cases. So far, we've covered data types and then creating abstract representations of these data types as variables. Now let's see how we can write Python scripts. Scripts are essentially text files with the .py extension. The simplest way to create a Python script is to go to a basic text editor, and instead of saving your text file with the .txt extension, you just change it to a .py extension, and it'll get saved as a Python file, which can then be understood by your Python installation as being a program as opposed to a text file. However, this isn't always the most convenient way to write Python scripts. Rather, it's common to use an IDE, which stands for Integrated Development Environment. And all this is a application that enables you to write Python scripts and really any other script for a programming language. Some very popular ones in the space are VS Code, PyCharm, and among data scientists, Jupyter Lab is very popular. Just to show you what that looks like, here we have VS Code. I'm going to open a folder. I'm going to open this folder called Python QuickStart, which is freely available on the GitHub. And so we see that there are already some files here, but I'm actually just going to create a new one. So I'll create a new one and I'll call it Python example. And then I'll be sure to create it with the .py extension. And now we'll have this script here and we can start writing a Python script, writing a program. Here I'm going to create the ceremonial first program that every developer writes, which is print hello world. What this is going to do is if we go to our terminal, I'm going to quit out of Python. I'm going to clear this. I'm going gonna hit ls, which allows us to see all the folders and files in the current directory. And we see that our Python example.py is sitting right here. I'll type Python and then I'll copy paste this here. If we run that, we see our program prints hello world. That's the simplest Python script that we might create, and I used VS Code to do that. But you can of course use whatever IDE or application you like to create Python scripts. Another one that I've been playing around with recently is called Cursor, which kind of went viral on Twitter. And the thing with Cursor is that it's AI native. It integrates large language models into the user experience to help you write code faster. And of course there are other IDEs and co-pilots that do things like that as well. Next, we're going to talk about loops and conditions. At this point, it'll probably be best if you're running these code examples to be typing these into a Python script which you can run, because these examples are going to run over multiple lines. It won't be something that you can easily write and debug within the terminal itself. And I can do that a little bit as we go along. First, let's talk about a loop. And all a loop does is it runs a chunk of code multiple times. One of the most popular loops that you're going to see is a for loop. Here's a very simple for loop that's going to iterate over a sequence of numbers. So range 5 creates a sequence of numbers of length 5 spanning 0, 1, 2, 3, and 4. And then what the for loop does is that it's going to iterate along this sequence one element at a time. Then we're going to print each element as we go along. So if we did this, this is what would get printed out in the command line. We can quickly see what this looks like with our VS Code script. So let's just write for I in range 5. We'll make sure to put the colon there, and then we'll just do print I, and we'll save that. Then we'll open up our terminal again. I'll hit clear. And then I'm going to run that same command from before. So Python and then python-example.py. So if we print that, we see our hello world from earlier, but then we're also seeing each element in that range being printed out. Another example is we can iterate over items in a list. Let's say we have our user interests again of AI, music, and bread. We're not just limited to iterating over numbers in a sequence. We can also iterate over the elements themselves in lists. If you're used to programming in C or one of the lower level languages, this might seem like magic or something. At least it was for me when I first started learning Python. And this makes a lot of use cases pretty convenient when you can iterate over items themselves. So if we run this script, what's going to get printed out are each item in this list: AI, music, and bread. Finally, we can also iterate over items in a dictionary. So if we create a dictionary, and then here I'm going to iterate over the keys in this dictionary. .keys will extract each key from this dictionary and give us the ability to iterate over them. So what this is going to be is a sequence of keys. It's going to contain name, age, and interests. So we're going to iterate over those. And then we can access the values of the dictionary by using the key. So here it's going to print the key itself, like name, and then we can print the value corresponding to that key using this syntax. We have the user dictionary, square brackets, and then the key that we want to reference. So if we run this, this is the output that we'll get. So we'll have name equals Shah. Name is the first key. Shah is the value corresponding to that key. Then we have age and interests. Next, let's talk about conditions, which allow us to program logic with Python. A fundamental example of this are if-else statements. One way we can use this is if we wanted to check if the user is older than 18. For that, we would simply write something like if the user's age, here we're referencing the age value in the user dictionary. Here we're very intuitively checking if the value of the user's age is greater than or equal to 18. And then we have our colon here. And then if this statement is true, then Python will execute the following command. It'll print user is an adult. Recall the value for the user age was 29, so this is true. Thus, Python should print this string here. And indeed, that's what happens. Alternatively, we can also have an else. Not only will it do something if it's true, if it's not true, we can have Python do another command. Here we're going to check if the user is older than 1000, and if not, we're going to print they have much to learn. Here the user's age is 29, which is not greater than or equal to 1000. So instead of executing this command, it's going to jump down to this else and print this. And so this is what we'll see in the command line. But we can also bring loops and conditions together. So an example of this is if we wanted to count the number of users in a list that are interested in bread. Here we're going to define a user list, which is a list of dictionaries, and it's going to have two elements. We'll have the first element being a dictionary corresponding to the user Shah, and then we'll have a second dictionary corresponding to the user Iffy. Then we're going to initialize a count variable. So we have this variable called count, and we're going to set it equal to 0. Then what we're going to do is we're going to loop through each element in this user list. So we have two elements here. So we'll start with this element and then go to the second element. Then for each user, we're going to evaluate this condition. We're going to see if bread is in the user's interests. Breaking this down, for user 1 is going to be Shah. User is going to be a dictionary. Then we're going to extract the value corresponding to the interests key. That's going to be this list here. And then we're going to evaluate whether bread appears in that list. In this first case, bread indeed is in the list. So Python's going to execute this line of code, which takes the count variable, which is currently 0. It adds 1 to it, and then it updates the count variable from being 0 to 1. And for people who are new to programming, this may be unintuitive because when we see equal sign, we might think of math, where the left-hand side is supposed to equal the right-hand side. However, equal here isn't saying that the left-hand side is equal to the right-hand side. What it's saying is we're assigning this variable count equal to whatever is on the right-hand side here. So this is a very common way of updating a variable in a for loop. So we just did that for element 1. Now we're going to go to element number 2, Iffy, and we're going to run the same chunk of code. So we'll evaluate the interests. We'll see if bread is in there, and we can see that bread is not in Iffy's interests. So nothing is going to happen. It's not going to execute this line of code, and it'll just continue. So at the end of this, we can print the count, and what we'll see is that one user is interested in bread. And so you can already see through the very simple elements that we've talked about so far. We've talked about lists, strings, integers, dictionaries. We've talked about for loops. We've talked about if-else statements. We've talked about printing values. And just with these basic building blocks, we're able to create this more sophisticated program that counts the number of users interested in bread. Next, let's talk about functions. These are operations we can perform on specific data types. We've already seen some examples of functions. One is the print function, which simply prints the input to the command line. Here we have a for loop that's going to iterate through all the keys in a dictionary and print the key and the corresponding value. So here we're using user dict. So if we recall, it's just this dictionary here. We run this script, it's just going to print the key value pairs in this dictionary. Another example of a function is type, which returns the data type of an input variable. Here we're going to do a similar thing, but instead of printing the value corresponding to the key, we're going to print the type of the value. If we do that, what's going to output is not the values themselves, but the type of each value. So name is a string, age is an int, and interests is a list. This is super handy because a lot of times you'll have these errors popping up in your code, and simply printing variables and their types types can often give you a better understanding of what's going on and help you debug the program. Another function is len, which returns the length of an input variable. Here we're going to print not the type of each value, but the length of each value. However, when we run this, we actually get a type error because this function len is not defined for integers. So although we got something for name, the length of name was 4 because it consists of 4 characters. Len is not defined for integers, so it threw an error. And as a bonus, if we were to compute the length of interests, we would get 3 because it consists of 3 elements. Len is an example of a function that's only defined for specific data types. So unlike print and type, which are defined for every data type, len is not. However, there are several other examples of data type specific functions. Here's a set of functions defined specifically for strings. So let's say we have the string Shah, which lives in this dictionary here. If we wanted to make all the characters in this string lowercase, we could use this .lower function that'll print the string like this. We can similarly make every character uppercase, and that'll print this. We can also split strings to convert them into lists. So we can split Shah on H and A, and what that'll create is a list with 2 elements corresponding to S and W. Another handy function for strings is .replace, which allows us to replace an arbitrary sequence of characters in a string with another. So let's say we wanted to replace every W in this string with WHIN. This will print Shaheen, which is my full name. Similarly, there are a set of functions specifically for lists. So let's say we have this list of interests here, AI, music, and bread. If we wanted to add an element to the end of this list, we can use the .append function. If we did .append entrepreneurship, that would update the list to this. If we wanted to remove a specific element from the list, we can use the .pop function and specify which element we want to remove. So if we did 0, that will remove the 0th element of this list and return this. Finally, if we wanted to insert an element into a specific place in the list, we can use the .insert function, specifying the element and where we want to insert that element. So if we did .insert 1 AI, we would insert AI into the second place of this list. And then finally, we have a set of functions for dictionaries. If we wanted to extract all the keys from a dictionary, we can use the .keys function, which is something we've already seen before. So this will extract all the keys from a dictionary, which we can iterate through using a for loop, for example. We can do the same thing for values using the .values function. So now we see the values from the dictionary. We can also access the items of a dictionary, not just the keys or the values, but the key value pairs. That'll look like this. And then if we print the items of the dictionary, we see that name is no longer included. Then if we wanted to add a new item to a dictionary, we can simply specify the new key name in square brackets of that dictionary and set that equal to a specific value. So if we wanted to add name back in, we could use this, and then printing the items, we can see that name has been added back into the dictionary. However, we're not just limited to Python's out-of-the-box functions. We can also create our own custom functions. So these are called user-defined functions. An example of this might be taking in a user dictionary and printing out all the user's information in a sentence. So this is the same thing we did earlier using a formatted string. However, here we're going to define a function to do it. You'll also notice that I used the triple quotes to create a string here that describes what the function does. This is called a docstring, and this is just a handy way to document what your function is doing so that other people can better understand your code, and also helping your future self understand what this function is doing. Once we define this, we can use this function by passing in our user dict, and it'll output this string, which I call description, which we can then print. If we print this, we see it says Shah is 29 years old and is interested in music. However, if we just wanted to do this once, there's not a whole lot of upside in creating a custom function. But if we wanted to generate this user description many times, functions are super helpful, because now when we want to do the same thing for another user, we simply pass in a new user dictionary to this user description function and print the result. So if we want to do the same thing for Iffy, we see it says Iffy is 27 years old and is interested in marketing. Next, we can do something a bit more complicated and create a function to count the number of users interested in an arbitrary topic. This will be pretty similar to what we did before, but instead of just looking at the number of users interested in bread, we'll have the topic of interest be an input to the function. Here we'll initialize the count again as 0. Then we have our if condition within a for loop. So we'll loop through an inputted user list. We'll see if the inputted topic is in the user interests, and if it is, we'll add 1 to the running count. Then once we make it through all the users in the list, we'll return the count. With this function, we can define a user list. So we'll have 2 users. We'll have user dictionary corresponding to Shah, and then we'll have new user dictionary corresponding to Iffy, and we'll select an arbitrary topic of shopping, and then we'll compute the count using our user defined function here. Then we'll print the count using a formatted string. What the output of this will be is 1 user interested in shopping. So far, we've seen the power and flexibility of Python. And in fact, Python can be used to implement any arbitrary program. But of course, if we had to implement everything we wanted to do from scratch in Python, this can easily become very time consuming. One of the key upsides of Python is that there is a vibrant developer community and a robust set of open source Python libraries. What this means is, for virtually anything you might want to implement in Python, there's likely already an open source library that exists for that. So talking about the AI and data science space, here's a visualization of some handy Python libraries. So of course, this is a non-comprehensive overview, but this is a set of libraries that will be helpful to any data scientist or AI engineer. So under data frames, which are convenient ways to structure data for analysis, we have pandas and polars. For data visualization, we've got matplotlib, seaborn, and plotly. For basic machine learning, we've got sklearn and xgboost. For deep learning, popular libraries are PyTorch and TensorFlow. For more modern generative AI tasks, there's the Transformers library and OpenAI's API. And then for web stuff, for making API calls and formatting HTML text, there's the request library and Beautiful Soup 4, respectively. In order to install these libraries, we can use pip, which is Python's default package manager. So if we wanted to install, say, NumPy, which is a fundamental library for doing math in Python, we can simply type pip install NumPy at the command line. With NumPy installed, we can do several things which are not possible with basic Python. The first is we can create this array data type, which mimics a vector or a matrix from linear algebra. So if we want to create a one-dimensional matrix, we could do it like this. If we wanted to multiply that matrix by 2, we could simply multiply by 2. If we want to create a two-dimensional matrix, we can concatenate together multiple one-dimensional matrices. Here we see a 3x3 matrix. And then if we wanted to do matrix multiplication, we can use the matmul function in NumPy. And so this will automatically do matrix multiplication for us. And of course, there's several other things that you can do in NumPy, which you can find in the example code on the GitHub repository. And the last thing I'll say about libraries is creating virtual environments. When using open source Python libraries in your projects, every project is going to have a set of dependencies, a set of libraries that it needs in order to execute successfully. For these types of projects, it's a best practice to create a virtual environment. All this does is keep track of all the libraries and their versions needed for your project. To do that, we do python-m venv. This is saying that we want to create a new Python virtual environment, and then we can give it any name we like. So here I called it my-env. Then we can activate this virtual environment. With Mac and Linux, you can type source my-env/bin/activate, or if you're in Windows, you can just run this batch file like this. Then with that virtual environment activated, you can install all the libraries you like using pip. Now let's get into the example AI project. So up until this point, we've just covered the basics of Python. We haven't done anything that could be considered AI. So let's see what implementing a simple AI project might look like with Python. Here, what I'm going to do is write a program that can summarize and extract keywords from research papers. This example, along with all the other code snippets we've seen so far in this tutorial, are freely available at the GitHub repository linked down here and in the description below. Our first step is going to be to install all the required libraries for this example. Just like before, where we did pip install and had a specific package name, another way we can install libraries is from a text file that lists several libraries that are necessary for a project. Here I've created a requirements.txt file available at the GitHub, which lists all the libraries. We can actually look at that here. So I've opened it up in VS Code, and we can see that it lists several library names along with their versions. So when we run pip install -r requirements, what pip does is it goes line by line through this text file and installs each of these libraries and the correct version. So we can actually see what that looks like real quick. So we can do python -m venv, and I'll call it my environment like before. And then since I'm using Mac, I can write source my env, so whatever virtual environment name you chose, bin/activate. Now you can see that our terminal looks kind of different. We have this my env sitting here. What we can do next is to install all the requirements. We see that I have the requirements file sitting right here in the current directory. So I can install all of them like this. So I'll do pip install -r, and then I'll put the name of the requirements file .txt. I'll run that. Then pip will go ahead and just automatically install all the project libraries. Then we can double check that by doing pip list. So this will list all the packages, and we can see that everything has indeed been installed. Next, we can go into our Python script and import the necessary libraries. We're going to import fits, which will allow us to extract text from PDFs. We're going to use the OpenAI Python API, and then we're going to import sys. Finally, I will import my OpenAI API key. Here I have a separate Python script called sk.py, and what I'm doing is importing a variable called my_sk. My_sk is a string which contains my OpenAI API key. I'm importing it in this way just for security reasons. I don't want to hard code my API key in the example code. That's just not a good practice, because if you forget that you put your API key in a script and you share it with someone or put it up on GitHub, then other people will be able to use that API key and they might rack up a bill that you'd be responsible for. Just to see what this sk.py file looks like, so if we go here, I don't actually have my API key here because this is the version on GitHub, but what you can do is just copy paste your API key into this Python file and it should work fine. Alternatively, if you're just running this locally and you want to do something fast, you can just skip this step and just hard code your API key. But of course, just be careful that you're not sharing that file with anyone. We'll import this variable from this sk.py script, and then we'll set our OpenAI.api key to my secret key. Next, we're going to define a function that will read in the text from a PDF. This function is actually kind of long, so I'm going to break it down into 3 parts. First, I'm going to define our function that's called extract abstract. And if you're not familiar, an abstract is like a summary paragraph of a research paper that is at the beginning of that paper. Extract abstract will take in one input, which will be a string specifying the path of the PDF that you want to extract the text from. Given that PDF path, we're going to grab the text from the first page of that PDF file. The way we do that with this fits library is we do fits.open PDF path as PDF. Basically what this is going to do is create this PDF object that allows us to access the text in the PDF. So here we're going to get the first page of the PDF like this. So we're grabbing the 0th element from this PDF object, and that'll correspond to the first page. And then we can specifically grab the text from this first page page using this function here, .get text, and then we'll just say text here. Now all the text from the first page is represented by this text variable. Next, what we can do is extract the abstract from this text. So text is just a string, going to be a bunch of characters. So what we want is to find where in that string the abstract lives. The way I'm doing it here is that I'm going to find a start index and an end index. Basically, at what element does the abstract start in the string, and then at what element does the abstract end. Here what I do is I take all the text, I make it all lowercase, and then I do this find function. So what this find function is going to do is going to find the word abstract in this text, and then it's going to return the index number corresponding to where abstract is in this larger piece of text. Then we don't just want the start position, we also want the end position of the abstract. So this one's a bit more tricky because the PDF could come in many different formats. It could just have the abstract on the first page. It could also have the abstract on the first page and then go into the introduction, or many other possible situations. So here what I do is, if the word introduction exists in the text, what I do is I find where introduction is, then I set that as the end index. However, if introduction is not in the text, I'll just set the end index as none. So basically, we'll only care about where the abstract starts, and then we'll just consider the text until the end of the first page. What I do here is I grab the text starting from our start index all the way to the end index, and then I use this strip function, which will remove any trailing or leading white space from the text. And then there's one more step, because there's always the situation where the word abstract does not appear on the first page, so we need to account for that. Basically what we're doing here is we're checking if the start index exists. So instead of checking whether start index is equal to -1, this is checking if start index is not equal to -1. So if it's not equal to -1, that indicates that abstract is on the first page of the PDF, and so we can move forward with the abstract as we have it. However, if start index is equal to -1, that means the abstract does not appear on the first page, so we'll actually return none. That's our extract abstract function. Next, we're going to extract a summary and keywords given in abstract. So we're defining another function here. It'll take in the abstract. We'll create a prompt using a formatted string. The prompt that we're going to send to GPT-4o Mini is summarize the following paper abstract and generate no more than 5 keywords. And then we're going to dynamically insert the abstract into the prompt. Then we're going to make our API call. Here we're using OpenAI's Chat Completions API. We can specify the model we want to use, which here we use GPT-4o Mini, which is the cheapest and fastest model OpenAI has. And then we'll send the model our prompt. OpenAI's API has the ability to create system messages as well as user messages. Here we just have the system message as "you are a helpful assistant," and then the user message, so this would be as if we went to ChatGPT and typed something in, will be the prompt that we defined up here. And then we set the temperature to 0.25. So loosely speaking, temperature essentially sets the randomness of the model's responses. A very low temperature means that the response will be very predictable, and a very high temperature means that the response will be very unpredictable. We'll make this API call, and this is essentially like us typing this prompt into ChatGPT and then getting a response. We can extract the response like this. The response will have a lot of different components to it, but here we're going to extract the first choice, we're going to extract the message from that first choice, and then we're going to extract the content from that message, and then we'll return that as our summary and keywords. Finally, we can bring everything together, and so here we're going to grab the PDF path from the command line. What this enables is that the user can type in the path of the PDF they want to summarize on the command line, and then Python will grab that text and store it as this PDF path variable, and then we can pass the PDF path variable to our extract abstract function. So this will return the abstract for us. Then we can use our summarize and generate keywords function to generate the summary. However, if the abstract is a none type, so basically the abstract did not exist on the first page of the PDF, Python won't execute this chunk of code and instead will jump to this else bit and print abstract not found on first page. That's the end of the script. Once we've written that, we can run that from the command line. So we'll do Python summarize-paper.py. So that's what I called the script in this case. And then here is the command line argument that we're going to pass to this Python script. This is our PDF path. So I have this files folder, and in that folder, I have a PDF called Attention is All You Need, which is a PDF of the famous Transformers paper. And then if we run this is the output we get at the command line. So we get a summary of the Attention is All You Need paper, and then we get a set of keywords courtesy of GPT-4 Mini. Here we covered a ton of information. However, there's still so much to explore when it comes to Python and AI. And I find the best way to navigate this ocean of information is to learn by doing. In other words, by building your own AI project. In order to do that, here I'm going to share 3 tips. First and foremost, use Google and ChatGPT generously. I don't know a single programmer who does not use Google or ChatGPT or some combination as a sidekick anytime that they're coding something up. And it's simply because that a lot of times you run into error messages that just don't make sense. And this is especially true at the beginning of your Python journey where you just don't have a lot of experience. These tools are just great ways to help you accelerate your learning and progress. Next is figuring it out is a key skill that you need to develop as a programmer. What this comes down to is just having the right mindset that even though something doesn't make sense to me right now, I'm capable of figuring it out. Instead of saying things like, I don't know how that works, change your mindset to, I don't know how that works yet. So often we're just one Google search or one explanation away from unlocking something that doesn't make sense. And this is something you'll run into over and over again as you learn Python. Finally, take the example code that I shared here and hack it to create your first AI project. Now that we have these large language models, which are capable of solving so many problems and accomplishing a wide range of tasks, integrating them into your Python scripts enable you to offload a large amount of software development and logic to the large language model, which allows you to move a lot faster. If you enjoyed this video, but you want to learn more, check out the blog in Towards Data Science. There I covered details I probably missed here. And although this is a member-only story, you can access it completely for free using the friend link in the description below. I'll also call out the GitHub repository, which contains all the example code that we saw in this tutorial. And as always, thank you so much for your time, and thanks for watching.